Good morning, students. Today, a new topic, that is excretion. Excretion means elimination of the metabolic waste. Elimination of the metabolic waste. And as you know, that the metabolism is the process, that is the chemical reaction take place inside cell, and if their product is somewhat harmful, because you know that each and every chemical reactions have certain useful substance which will be utilized by the individual, that is useful substance. If their product is not useful or if their product is harmful, then it is called waste product. So it is very much essential that if metabolic activity will take place, there should be a release of the harmful substances or the unusable substances. It is very much essential to get rid. If that will be accumulated inside the body, then it may have a harmful effect. So it is very much essential that it should be get rid, it should be out. And the process by which we can get rid that particular metabolic waste is called excretion. One of the important excreta is the nitrogenous waste. Nitrogenous waste. Of course, in addition to that, carbon dioxide is also excreta. Even excess of water is also excreta. Certain smelling agent is also excreta. Certain salt is also excreta. So the excreta may be in form of the nitrogenous waste, may be in form of the salt, may be in form of the carbon dioxide, or many more. And it is not essential that the excreta will be get rid from the body from the particular organ. It is of the several types, on the basis of the complexity of the individual, on the basis of the evolution of that particular individual. So, if you go through in the animal kingdom, then you will see that in protozoa, like amoeba, the plasma membrane is the excretory organ. Through this plasma membrane, they maintain the concentration of the salt and others by endosmosis, by exosmosis. So if the waste product will be accumulated inside the body of the amoeba, then it will be get rid, maybe in form of the vacuoles, and ultimately exosmosis will be there. In sponges, it is also an individual plasma membrane, that is the same way. There is no separate organ will be formed for the elimination of that nitrogenous waste. And Cnidaria, all are through plasma membrane. In case of platyhelminthes, the flame cell, there is a kidney-like structure, or the you can say that the excretory organ, it has such type of flame-like structures will be there, and they collect the waste product, nitrogenous waste product, and ultimately get rid of it. In Annelida, nephridia is there. In Arthropoda, most of the individuals have Malpighian tubules as the excretory organ. But in certain cases, green gland is also present in the excretory organ. In vertebrates, types of kidneys are there, and they are responsible for the elimination of the nitrogenous waste. We will discuss that on the basis of the types of nitrogenous waste, we can classify this particular vertebrate also. But here you will see that the vertebrate, most of the vertebrate have either poorly developed kidney or the well developed kidney, that is called metanephric, mesonephric, or the opisthonephric kidneys. And in case of plant, it has been observed that the stomata eliminate gaseous substance, bark accumulate that particular waste material, and ultimately get rid in periodic time periods. And one of the significant characteristic feature of the excretion in the plant that they utilize the excreta by accumulating it inside the tracheids, and which is responsible for the providing them strength. In this way we can say that the different organs are responsible for the excretion. Now come to the point that just I have told you that on the basis of the nitrogenous waste, the excretion is of many more types. Number one, if the nitrogenous waste is ammonia, this individual is called ammoniotelic. Ammoniotelic. If the amino acid, it is called aminotelic. If it is uric acid, it is called uricotelic. And if it is urea, then it is called ureotelic. Among them, one of the dangerous, one of the toxic nitrogenous waste is ammonia. So it is very much essential that the immediate get rid of the ammonia should be there. For this purposes, plenty of or abundance of water should be present there. So it has been observed that the most of the aquatic animals are aminotelic because they have no crisis of the water, they lead their life inside the water, so they can eliminate. But in case of human being, what happens? The ammonia is the product, metabolic product. Metabolic waste will be in form of the ammonia, and human being are terrestrial, so it can't lay out from the body in form of the ammonia because it has need of the plenty of water. Because of that, what happens, that ammonia convert into urea by a cycle that is called ornithine cycle. Ornithine cycle or urea cycle. Urea cycle. And then when it converts into urea, then urea will be eliminated out with the help of the kidney. It has been observed that the uric acid is insoluble in water. Generally, it has been observed that the uric acid is the waste product with the nitrogenous waste of the birds and reptiles. Birds and reptiles. You can observe whenever the fecal matter will be laid out by the birds or reptiles, in addition of that fecal matter, in addition of that stool part, there is a whitish granular substance or the whitish semi-liquid substance. In case of the bird, that is whitish semi-liquid substance, and in the case of reptiles, there is a whitish granular substance will be laid out, and that whitish substance is the uric acid and the other substance is the stool. So the urea, stool and the that nitrogenous waste will be eliminated out simultaneously. But the stool discharge, the defecation, is not considered as the excretion because that is not the metabolic waste. That is the byproduct, or that is the product of the byproduct of the, you can say that the undigested food materials. Of course, due to certain chemical actions, due to certain bacterial actions, that will be converted into different foul smelling agent or the others, but that is not the metabolic waste. So we can't say that the defecation or the stool discharge is the excretion, but it is a just elimination of the undigested food material, that will be studied separately. Now come to the human excretory system. It has been observed that in the lower abdominal cavity, a pair of kidney is present, which is bean shaped, dark brownish in color, and have two this type of tubes, one from each, will come out and stored into they store certain substance here. And this is called ureter. And this is called urinary bladder. And this is called urethra. And it has been observed that the drop-wise urine are collected here, and after getting the suitable height in this urinary bladder, there is the urge to micturate. In addition of that, it receives blood. It is impure blood. Here you will use impure blood, not the oxygenated or deoxygenated. It is impure blood and carried by the different part of body to the kidney, where purification will take place, and after purification it will go to the heart, and there they pumped out. So here, and this kidney is also called one word that is called renal. Renal kidney will be there. Kidney, the term renal is also used for the kidney. So you can say that it is renal aorta, a renal artery, which carry blood to the heart, to the kidney, where purification will be take place. Now, another it is called renal vein. We have discussed aorta and vein, artery and vein. The artery, which carry blood from the heart to the body, and here from the heart, different part of the body, then to the kidney, and from the kidney, this blood is going to the heart. So the veins are that particular blood capillary which carry blood from the different part of body to the heart. So this one is called renal vein. Of course, it carries oxygenated, pure blood, and it carries impure blood. And this is all about if you draw excretory system, then very easy part we can add here. It is the renal vein, that is called urethra, and this is the urinary bladder, and this is the two kidney, a pair of kidney. Now you will have to study the internal structure of the kidney. If you cut the LS of the kidney, just we have studied two or three organ systems like alimentary canal, like respiratory system, like circulatory system, and among them the respiratory system, that is called lungs, and the circulatory system, that is the heart. Both are delicate delicate organs, so they have need of the extra protection, and because of that they are covered by the certain protective membrane. But here there is not protected by the membrane. It is a solid part. It is a solid substance, so they have no need of protection, and they are situated here in the pelvis zone. Okay. Now, if you cut a section of the kidney, then we can observe that it is like this. It is like this. It is called renal cortex, and this is called renal medulla. Before study of this particular internal part of the kidney, we must have a few simple idea about the unit of excretion, that is called nephron. Nephron is the unit of excretion. It has a bi-layered cup-like structure, having a well convoluted tubular structure, having a U-shaped tubular structure. Again it is convoluted tubular structure, and then it open in the certain thick tube. Thick tube. We have studied that each and every kidney receive renal aorta. Renal aorta. And this renal aorta divided into many more this type of thin tubes, and each and every tube is called efferent renal artery. Efferent renal artery, and this efferent renal artery insert inside it. It is called Bowman's capsule. This is called proximal convoluted tubule. This is called loop of Henle, and this is called distal convoluted tubule, and it is called collecting duct. Each and every this branch indicate that the distal convoluted tubule is opening inside the one collecting duct. It means a number of distal convoluted tubule open into the single collecting duct. Understand? Now, here you will see that the inside this renal medulla, there are so many pyramid-like structures are present. pyramids are present, and it is called renal pyramid. Each and every this tubes, each and every mark is called collecting duct. It means one pyramid contains if 100 collecting duct, and one collecting duct receives 100 distal convoluted tubules. It means 100 into 100 distal convoluted tubules. It means 100 into 100 nephrons are received by one pyramid. Okay. What are the product of this particular distal convoluted tubule? We will discuss it later on during the functioning of this particular. But just I have told you, we have to concentrate a simple ideas. We will have to take a simple ideas of the nephron because of the drawing this particular figure, and here is the collecting duct. Before that particular, it is something somewhat confusing, so I have drawn a figure. Now, come here. Now each and every this particular open into the, see here, 2 into 1, here it is also 2 into 1, here you will see here that it will come like this. You will see here that one here and another from this part to form one. It is also one. Now it will join to form 2. It will again join to form 2, and again now it will combine to form 1 and move like this. And one tube is also here. Just understand it. Renal aorta, impure blood. Impure blood. Renal vein, pure blood, and this is urine. Is the urethra. It means the urine is collected here, and that will be passed through the renal pyramid to the minor calyx, to the major calyx, to the cervix, and then to the urinary. Urine passes through the urethra. Here, millions of nephrons are present in form of this one. This nephron is present in this particular part, that is called renal cortex. And gradually it has been observed that the renal cortex received that nephron is opened inside this renal pyramid through collecting duct. Now what happens in collecting duct? See here. Whenever this efferent arteriole open into the Bowman's capsule, it will divide it into many tube-like structures, this type, and again this tube-like structure join here, and go out. It is called glomerulus. It is called glomerulus. This Bowman's capsule having glomerulus. This Bowman's capsule having glomerulus is called Malpighian body. Now, it divides into many more tubes, and it surrounds this one. It also surrounds this one. It also surrounds this. And ultimately all join to come one pure blood that is called renal vein. It means what happens here, you will see. This is called efferent arteriole. Renal vein, renal artery, divided into efferent arteriole, and one is divided into millions because in this particular cortex zone, millions of the nephrons are present, and each and every nephrons has need of the one efferent arteriole. So one efferent artery insert inside it, one nephron, and again this efferent, it is very thin, again divided into more thin glomerulus. Have significant characteristic feature because this particular thinness is helpful in the filtration of the blood. We will discuss it at the time of urine formation. Now it rejoined to form the efferent arteriole, and again it divided into many parts, and they are very much keen contact with these all parts, that is called proximal convoluted tubule, that is the loop of Henle, that is the distal convoluted tubules, that is the collecting duct, because not a certain useful substance will be laid out. They are in condition to reabsorb from the filtrate. And this is all about the nephron, one of the structure of the nephron and one of the structure of the internal part and the external part of the kidney. Now in the next lecture we will discuss how blood is filtered and how urine is formed.